Okey, bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera kepada semua. So, now we continue with another chapter for fluid mechanics, BNJ 20203, which will cover chapter 5, the momentum equation. Okay. So, in this chapter, you'll be introduced to, of course, to the momentum equation itself. So, apa yang kita tahu bila kita cakap momentum equals to, ingat tak lagi apa momentum equals to m times v. Okay, this is mass of an object times its velocity. So this is the basic definition of momentum, and in this chapter you will be demonstrated on how the momentum equations, okay, and also the principle of conservation of momentum will be fully utilized in order to predict forces induced by flowing fluids. Kan? So maksud dia, kita akan fully utilize these momentum equations and its principle in order to predict forces by flowing fluids. Okay, of course, when we talk about applications or to solve problems related to fluid mechanics, kita tak semestinya kita akan bergantung kepada satu-satu prinsipal je. Kita akan refer to other principle as well. As for this chapter, you will be also using the Bernoulli equations as well. Okay, so banyaklah application yang kita akan tengok lah based on case study yang kita akan refer later on. Okay, so these are basically what you will be gained after you complete this chapter. First of all, you to identify, you'll be able to identify the various kind of forces and moments that are acting on a control volume. Okay, so use the control volume analysis untuk determine the forces associated with the fluid flow, as well as use the control volume analysis untuk determine the moments caused by the fluid flow. Okay, so these are regarding the development of the momentum principle. So kalau kita tengok dekat sini kan, apa yang kita belajar sebelum ni adalah F equals to MA. F equals to MA is only applicable if, let's say, in solid mechanics, but for fluid mechanics it is different, because in fluid mechanics it is not clear what mass of moving fluid. Okay, so in order to solve for forces, for example, that are acting on a fluid, we should use different form of equation. Okay, nampak beza dekat sini. If let's say in a solid mechanics, kita boleh guna pakai F equals to MA, but in fluid mechanics kita tak boleh guna this equation. Kita kena guna lain equation. Itulah kegunaannya momentum equation, yang mana kita akan relate dengan how to find total force that are acting on the fluid flow based on this momentum equation. Okay, so first of all, macam saya cakap tadi, what is momentum? Momentum itself is defined as m times v. M is the mass of an object and v is the vehicle. Okay, so in Newtonian mechanics, the conservation of momentum is defined by Newton's second law of motion, in which it says that the rate of change of momentum of a body is proportional to the impressed action takes place in the direction of the impressed action. Okay, so apa maksud dia kat situ? Contoh macam I think last times in physics you have learned kan, contoh macam ada dua objek yang bergerak in different directions. Okay, once dia bertembung, dia akan create satu momentum yang mana the balls, both balls will moving on the same direction. Okay, which we refers to certain velocity. Okay, that is what it means by the impressed action takes place in the direction of the impressed action. Okay, so kat sini kita ada juga dalam bentuk linear momentum ataupun angular momentum. This is depends on the application lah. Dia akan jadi linear momentum if let's say the force they are acting on the body. Kalau force kita nak tahu kan, satu-satu force tu is a straight direction. But if let's say torque, kita akan consider an angular momentum. Tahu kan, torque equals to F times D, and the difference from force. Okay, so this is actually the general form where we say about the conservation of momentum. Kita akan express the momentum is a momentum of a system that remains constant when the net force acting on it is zero, and thus the momentum of such system can be said conserved. Okay, the momentum of a body will remains constant if the net force acting on it is zero. So momentum, the conservation of momentum tu will remain as long as tak ada force yang acting ke atas momentum tu. So it can be said that the system is conserved. Okay. Right. So ini yang mana kita nak relate. Macam mana kita nak kira force untuk fluid mechanics, kan? Macam mana kita nak kira force? Kita tak boleh guna F sama dengan MA kan? So kita nak relate to momentum. Macam mana kita nak relate force dengan momentum? Okay. So kalau kita the momentum equation is a statement of a Newton's second law and relates the sum of the force acting on an element of fluid to its acceleration or rate of change of momentum. Okay, so kita tahu F equals to MA. Okay, yang ni memang basic, kita tak kata dia salah, cuma je kita tak boleh directly pakai F equals to MA. Kita kena convert kepada momentum. Tu kita tahu what is an acceleration. Acceleration is change of velocity with time, kan? So kita boleh letak dv over dt. Okay, so kita tahu m times v is the momentum. So kita boleh write juga over macam tu. So dapat tak relationnya force dengan momentum, kan? So the sum of forces acting on an element of fluid to its acceleration or rate of change of momentum, kan? This is the momentum, jangan confuse lah. This is the momentum. So bila kita differentiate with time, dia dah jadi rate of change of momentum. This is how actually we relate forces and momentum. Kalau kita tengok kat sini sama So whereby the total force is the sum of force acting on the fluid system, and this mv is actually the linear momentum of a system. Okay, dia linear lah, sebab kita consider force. So kita boleh buat summation of force equals to change of momentum, ataupun yang ni dia bawa dt ke tepi, impulse momentum principle. Okay, yang pentingnya yang ni ini kita perlu faham macam mana kita nak relate force dengan momentum. Okay, and then this is whereby macam saya cakap sebelum ni kita akan relate dengan continuity and Bernoulli and so on so forth. So from continuity, kita tahu kan continuity tu macam mana. Continuity dia cakap apa yang flow in, rate of flow in sama dengan rate of flow out, and that is why kat sini dia cakap mass flow in equivalent to mass flow out. So kita bagi contoh, this is one pipes. Kita ada A1 U1 dengan density 1 and A2 U2 and density 2. So based on continuity, rho AU at position 1 equals to rho AU at position 2, which is the mass flow rate. Okay, so if let's say a mass entering a system tube, kita consider as a U1 dt. Okey, dia masuk dekat sini je contohnya, sampai sini. So yang ni semua ni lah. Okey, this area je dulu. Okey, so kita boleh cakap volume times the density. So dia punya dia punya velocity hanya bergerak sebanyak delta t sahaja. Okey, so kita boleh consider momentum entering. Dia ada momentum entering and momentum leaving. So momentum entering dia adalah rho A1 U1 delta T U1 and delta T U2 kalau dekat leaving. Okay, so based on the equation sebelum ni, force is equal to rate of change of momentum. Kita boleh ganti nilai ni ke dalam ni. Okay, kan? Sebab kita tahu kan, apa tadi based on yang ni, F equals to change in rate of change of momentum over dt kan. So total force equals to and selalunya macam ni lah, m int salah. Macam ni saya tulis kat sini lah, m out minus m int over delta t. Okay, so actually kan, in the actual dia ada beta kat sini, which is the consider as a correction factor. Tapi tak apa, for this initial stage kita abaikan dulu. Okay, that is why kat sini kita akan dapat something macam ni. Okay, kita replace m entering dengan m leaving dekat dalam ni. Lepas tu kita akan dapat with the knowledge of volume flow rate equals to A1 U1 A2 U2. Q ni adalah volume flow rate equivalent. Kalau mass flow rate kita tahu kan, usually kita belajar kan, density equals to mass over volume. So mass equals to density times volume. So sama juga, mass flow rate equals to density times volume flow rate. So kita tahu V naught ataupun Q equals to A1 times U1. That is why if let's say mass flow rate, kita akan dapat rho times AU. That's why kita dapat yang ni sebenarnya. Yang tu yang beza mass flow rate dengan volume flow rate. This is volume, this is mass flow rate. Ni volume flow rate. Okay, so kita tahu mass flow rate equals to rho AU. Ataupun kita guna ni lah, volume flow rate dulu. Kalau kita tengok sini dia guna volume flow rate kan, kita tahu delta T can be cancelled out. Okay, yang leave, yang tertinggal hanyalah rho A U2 U2 minus rho A1 U1 U1 kan. Since Q equals to A1 U1, so kita tahu benda ni adalah Q. Benda ni adalah Q. That's why dia bawa keluar rho Q, and then in bracket U2 minus U1. So this is basically an important equations that you should memorize dalam momentum momentum equations punya chapter. Okay, you will be using this formula quite a lot in solving fluid flow related problems. Okay, so actually dekat sini kita dah derive macam mana kita nak relate to momentum equation. Sebab apa? Sebab kat sini sebenarnya macam saya cakap tadi kan, this m dot ni adalah rho AU ataupun rho Q kan. So sebenarnya dekat sini kita boleh sambung F equals to m dot U2 minus U1 kan. So yang ni dah jelas maksud dia dekat sini, total forces equals to rate of change of momentum. Momentum out minus momentum in. Okay, but in the past there have been questions on the derivation of a momentum equation for a fluid flow in a control volume. How to show? Actually dekat sini pun dah boleh tengok. Cumanya kat sini saya akan tunjuk in a much proper way on how to derive the momentum equation. To derive momentum equation means daripada asal ni, okey, kepada yang kita nak dapat ni. Kita nak tunjukkan total forces equals to rate of change of momentum kat sini. Okay, so how to start? Okay, so macam tadilah kita tahu Newton's second law kan, F equals to ma. Betul? Lepas tu ini sama juga m dv over dt kan, change of velocity kan, acceleration. Tu kita boleh buat d over dt kan, mv. Kita keluarkan d over dt tu supaya kita dapat mv kat sini, in which this itself is actually, saya tukar colour sikit, is actually rate of change of momentum. Okay, this is the rate of change of momentum. So kita consider, next kita consider satu control volume. Macam case tadi, let's say this is satu control volume yang mana dia ada inlet dengan outlet. Dekat inlet ni kita ada V1, A1 and row 1 contoh dekat sini kita ada V2, A2 and row 2. If let's say kita consider dia bergerak, the fluid flow bergerak sampai sini je. Sampai sini kita ada the area is equivalent to V1 dt. Dia bergerak pada masa dt saja, the velocity Okay, so kita boleh calculate sebenarnya the volume entering yang ni volume entering kan dekat V1 entering ataupun volume, okay, equals to volume in would be equivalent to volume out, outing ataupun leaving lah, tak kisahlah. And this is based on this control volume in which equivalent to, kalau kita kira volume volume adalah area times dia punya ni, and adalah V1 delta T. So this is the volume. Okay, area kat depan tu kalau dia circular times berapa jauh dia pergi. Okay, so sekejap saya buat garisan dulu. Okay, yang tu kita dah settle one part. Lepas tu kita tahu what is momentum. Momentum is equivalent to m times v, in which kita tahu mass equals to apa? Density time volume kan? Alright, so kita ganti mass ni tadi dengan volume times velocity. V ni saja kita buat bentuk macam A terbalik ni sebab kita nak bezakan dengan velocity Okay, so this is also equivalent to kita tarik balik volume ni tadi, kita ganti kat sini. So sekejap saya ambil color lain supaya boleh nampak this is the volume tadi. Okay, kita replace masuk dalam ni so yang ni tadi volume ni. Okay, so yang ni akan jadi row, and then contoh kat sini kalau yang ni A1 lah kita consider sebab dia sama leaving outing. So A1 and then V1 delta T. Yang ni contoh kat position 1 lah, V1. So kita akan dapat benda ni. Okay, momentum adalah benda ni kan. So dari sini kita dah boleh buat momentum in dengan momentum out. Momentum entering is equivalent yang ni lah sebenarnya, row A1 V1 delta T V1. okey, ataupun yang kedua momentum outing atau leaving lah. Okey, equals to rho dekat position tu kan, A2 B2 delta T B2. Okey, so kita dah dapat dua-dua ni, momentum in dengan momentum out. So next, daripada benda ni tadi yang kita tahu total force equals to rate of change of momentum kan. So kita guna apa yang kita dapat, momentum in momentum out ni. So tak apa, saya tulis balik. F kita tahu sama dengan d over dt mv kan, di mana rate of change of momentum tadi adalah momentum out minus momentum in over delta t ni. Okay, alright. So equivalent to, kalau yang out tadi berapa tadi, rho A2 B2 delta T B2 minus rho A1 B1 delta T B1 over delta T kan, in which kita boleh cancel out this one change in time lah, this one, betul tak? Alright, so apa dia jadi sekarang? Kita dah jadi force equals to rho A1 A2 B2 B2 minus rho A1 B1 B1. Okay, so dari sini kita tahu volume flow rate equivalent to A times V kan, yang mana A based on continuity A1 B1 equal to A2 B2, betul tak kan? So kat sini, dari sini kita boleh buat F equals to rho Q V2 minus V1, betul tak? Lepas tu kita tahu pula, kita tahu mass flow rate equivalent to rho times volume flow rate kan. So kita replace benda ni dekat sini. Okay, so bila kita replace, kita akan dapat, sekejap saya ambil ni balik, equals to mass flow rate V2 minus V1. Okay, so kita dapat kat sini total force equivalent to rate of change of momentum, yang mana kita dapatkan balik yang kita explain dekat awal-awal tu, yang mana kita boleh relate. In order to get total forces dalam fluid flow tu, kita relate dengan momentum equations. So if let's say the question asks you to derive a momentum equations for a fluid flow in a control volume, this is the structure or the langkah-langkah, step or procedure that you need to show. Okay, okay, and now we proceed with the cases in which we will utilize the momentum equations. Okay, so the display here shows the momentum equations for a two-dimensional flow. Two-dimensional flow means that we only consider the x direction and y direction. Okay, so consider that this is a two-dimensional system for a flow in a stream tube. So we will divide the discussion into two parts, in which the first part we will consider the x direction and the second part we will consider the y direction. So kita go through satu persatu lah. So if let's say this is the control volume. Okay, the control volume which dia ada kat sini, we have velocity inlet U1 and also velocity outlet U2. Okay, And things that to be noted is that the U1 and U2 dia bukannya horizontal, dia ada angle. Kalau ada angle kat sini, that is why we need to consider both direction. Okay, means that dekat sini kita ada U1 in which in X component, and also U1 in Y component. Similarly dekat sini pun sama, kita kena consider U2 but at Y axis, and also U2 at X component. Okay, so we need to pecahkan kepada dua components, because the inlet dengan outlet or U1 and U2 dia masuk ke control volume and keluar dari control volume dengan angle. Dia ada this angle value that we need to take into consideration in our calculations. So macam yang kita tahu sebelum ni, what is a total forces? Total forces equals to m dot U2 minus U1. But this one is a general equation. But for those related questions in which we need to consider both X and Y, kita kena pecahkan macam saya cakap tadi. Kita ada X direction dengan Y direction here. So for this slide, kita fokus on the X directions. So kita tahu total forces in X component. So usually lah kita kena decide lah for X component which direction is positive value. So kita for this case, we will consider those moving on the right is a positive value. Okay, so total forces in X direction will be equal to the rate of change of momentum in the X direction. Okay, so kita tahu this is the equation. So apa yang kita kena cari adalah kita kena cari U2 and U1 but in X component only. Okay, macam saya cakap tadi, dia bukan horizontal kan, dia ataupun vertical, dia memang ada komponen X and Y because of the angle it created. Okay, so kalau X component, kita just consider U2 cos theta 2 minus U1 cos theta 1. Theta 2 and theta 1 bergantung kepada inlet dengan outlet ni sahajalah. So it is easy sebenarnya, tak ada isu pun. Cumanya instead of a regular this equation, kita kena convert to this equation. And then dia sama juga dengan, maksud dia sama macam ni. Okay, and then we know that this mass flow rate equals to this rho time volume flow rate ataupun PV dot. So ini dengan ini samalah, interchangeable, don't be confused. This is the volume flow rate. So ini sahaja untuk X direction. Similarly untuk Y direction, instead of cos theta, kita consider sin theta kan. So konsep dia sama juga, dia ada X and Y kan, X U1X and U1Y, and then kita ada U2Y, U2X. So untuk ni dia adalah U2Y sin theta 2. Ini adalah U1I sin theta 1. So we replace here, and U2 minus U1, kita akan dapat this. Okay, it's easy right? Okay, so ini dia berbalik kepada equation asal. Kita tahu total force exerted on the fluid is equivalent to the rate of change of momentum through the control volume. So ini yang kita guna, yang kita apply the momentum equation, yang mana total forces equals to rate of change of momentum. Okay, so the basic equations is this. Okay, saya rasa semua dah familiar kan, berapa kali kita ulang. Okay, cumanya dekat sini dia dah introduce another coefficient in which is called the beta, or the momentum correction factor, in which introduced here. Okay, So what does it means actually? Okay, so momentum correction ni maksud dia macam satu coefficient yang mana dia akan correct the actual factor, in which can be calculated through this equation. Okay, tapi usually lah in your cases they won't be questions that ask you to calculate the value of beta. If let's say kalau ada pun, usually beta is given, in which you need to just replace into the equations given. Okay, and thus this will become the final momentum equation, if which we consider the momentum correction factor. Okay, right, and hence kita dah dapat the value of f. Kalau kat sini kan, kita dah dapat value of fx dengan value of fy. Next, what we need to do is that we need to find the resultant. The resultant similar concept lah, fx squared plus fy squared, square root of all kan. And then how to find the angle which this force are acting adalah the inverse tan fy over fx. This is, saya rasa quite general Okay, so this is the resultant force acting on the fluid in the direction of the motion. Okay, and by Newton's third law, the fluid will exert an equal and opposite reaction on its surrounding, and so on and so forth lah. Yang ni semua dia ulang-ulang balik. Okay, the value of F is positive in the direction which V is assumed to be positive. Okay, yang ni macam yang kita set tadi ya, asal-asal. If let's say satu-satu control volume tu, okay, so if V this direction, kita consider Fx follow the direction of velocity ke kanan adalah positif. So kita tahu okay, tak apa, yang tu next, untuk next slide. Okay, so as per right now, you need to know macam ni sahaja, macam mana kita nak dapatkan fx, macam mana kita nak dapatkan fy, macam mana kita nak dapatkan resultant, and then how to get the angle in which the force are acting, and so on. Okay, alright, so next is ni macam example let's say this is a control volume which comprise of a fluid contained in an expander, okay, at any instant. So kita tahu this is the control volume. Saya kasi satu control volume ni from point 1, 2, 3 and 4, and patah balik point 1. So kalau kita tengok dekat sini, kita ada dekat inlet, kita ada V1 and P1, usually is given, but dekat V2, and then tengok direction of P2 is always towards the control volume. Yang ni kena take note P2 is always towards the I mean not just P2, pressure we always towards the control volume. Okay, dia tak follow macam velocity in ke sini, out to the atmosphere kan. Kalau pressure, it will be acting on the control volume. So P1 is in this direction, P2 is in this direction. And other forces that you might be considered is the forces due to the weight of the expander, which is F equals to mg, and then also the reaction force. This is the reaction force that you calculated before lah, this one. Okay, usually the reactant force is equivalent to the minus the resultant force, the resultant force is equivalent to the inverse of the reaction force. Reaction force ni actually force yang needed to maintain the conditions. Okay, tak apa, lepas ni saya explain lagi. Kalau tengok kan kat sini contoh, okay, the reaction force is always inverse ataupun negative the forces in x and y direction. Okay, right, this is just an example. So later on we will proceed with some questions in order for you to understand further lah. Okay, so bila kita cakap pasal, kita dah tahu the basic equation is total forces is equals to rate of change of momentum kan, V2 minus V1. Okay, actually this total forces is also can be divided into few. Kita ada Fr, which is the resultant of force, the Fb, which is due to the gravity, and also the pressure force. Okay, so this is usually Fr ni in x and y directions, and then body force is due to the weight or the gravity, and also Fp is due to pressure, in which Fp equals to Pa lah, and the forces acting on the control volume. Okay, so just nak mention dekat sini, total forces yang ni sebenarnya in actual can be divided into 3. Okay, you need to know this. Okay, so ada item penting juga kat sini. The force exerted on the fluid on the solid body touching the control volume is equal and opposite to Fr. So the reaction force is actually minus the total force. Okay, the force exerted by the fluid on the solid body touching the control volume is equal and opposite to Fr. Okay, the reaction force or the resultant force is minus the reaction force. Okay, jangan confuse resultant and reaction. Okay, so yang ni take note. Okay, sometimes will be asked in the exam. Okay, alright. So these are the step-by-step analysis in which you need to be considered in solving those related momentum equations punya questions. So macam yang step by step saya tunjuk tadi, kalau kita dapat satu-satu masalah tu, first of all we need to define the control volume. After we define the control volume, we need to decide on the coordinate axis system, dia punya x and y. If let's say macam case study, dia ada angle kita kena consider which one x and y, and also cos theta and sin theta and so on lah. And then we need to calculate the total forces in which comprise of Fp, Fb and Fr. In the end kita kena keep on familiarize dengan this equation V2 minus V1. Tapi sometimes kita kena consider ni lah, dia ada correction factor. Okay, alright. And then next okay, in this topic we will also consider a few application of the momentum, in which examples include force due to the flow of fluid around a pipe band. Okay, yang ni kita akan tengok juga contoh-contoh soalan berkaitan dengan force due to the flow of fluid around a pipe band, and also force on a nozzle at the outlet of a pipe, impact of a jet on a plane surface, and lastly kita akan consider juga the application of momentum in Pelton wheel. What is Pelton wheel? So later we will go and see in details about Pelton wheel as well. Right. So okay, ini sebenarnya consider the first part, which is force due to the flow of fluid around pipe band. Sebenarnya contoh-contoh yang tadi saya tunjuk pun related to these cases yang mana kita ada pipe band. Okay, so kita tak apa, kita baca dulu. Let's consider a fluid flow through an expander. Okay, the expander is held vertical plane. The inlet and outlet velocity are given by, dia ada V1 and V2 as the inlet and outlet as shown in the figure. The inlet and outlet pressure are also prescribed as P1 and P2. Kita ada pressure at both end. The velocity and pressure at both inlet and outlet are assumed to be uniform, means that the magnitude is uniform. The problem is usually posed for the estimation of force required at the expander support to hold in its position. So means that usually this question macam consider macam tadilah kan, kita akan dapatkan value of, kalau kita tengok dekat sini dia ada x and y components kan. So what we need to do is that we need to get the reaction force, in which equivalent to the minus reaction force is actually the force or the the reactions that it needs force to maintain or to hold this expander position, somewhere dekat sini lah. So we have Fy dekat sini, kita ada Fx, usually this is the Fr. Okay, and then the reaction is equivalent to the minus this value. Okay, alright. Okay, ni kita nak consider the same case the same case kat sini. Alright, so kita consider the same rumus. Actually yang ni terbalik ini total force dia bubuh belah kanan pula. Okay, equals to this m dot v2 minus v1. Alright, so kalau kita tengok kat sini, dia dah pecahkan Kalau kita tengok ini, alright, sekejap saya tulis actually ini adalah untuk dia cari the value of fx. Ini dia cari untuk value of y, total force in x direction and total force in y direction. So kita tengok kalau total force kan, macam saya cakap tadi, dia ada few that we need to consider. Kita ada kita ada due to gravity, due to apa lagi tadi sekejap, saya pun nak kena tengok balik. We have due to the gravity, due to the force and due to the pressure Okay, Fp, Fr and Fp. Okay, so these are all the forces that need to be calculated, okay, on this side. Okay, F total dia. So kalau kita tengok at this condition, this control volume, what total of forces in x direction that we can consider? First of all, we have, of course, we have Fx, sebab kita consider Fx kan. And then in term of pressure force, kita ada P1A1. Okay, because it is acting horizontally, dia tak ada angle kita consider yang ni horizontal Okay, and then sebab ni kita consider x ke kanan Okay, so kita ada, kalau dekat P2 ni, P2 tengok direction dia ke kiri with theta. So that is why we have minus P2 A2 cos theta. Dia punya pressure F equals to PA. So forces dia in negative value disebabkan direction dia adalah ke arah control volume, which is ke kiri. That is why dia ada P2A2 cos theta. So take note on that point Okay, so for the left hand side, kita ada rate of change of momentum. Similarly, kita consider V2 minus V1, in which V2 is equals to V2 cos theta lah, sebab dia ada angle kan. Semua condition at the outlet, kita ada angle yang kita need to consider. So kita ada m dot V2 cos theta, and then we rearrange, we will get this equation lah. Okay, so similarly on y component, we need to consider additional, which is force due to the gravity. So for this part, kita consider yang ni adalah to the right is positive, yang ni upward is positive. So kita ada minus mg sebab gravity is ke bawah. Okay, and then kita ada Fy biasalah dia ke atas. And then kalau dekat area inlet ni, kita tak ada y component sebenarnya, sebab everything is horizontal macam saya cakap tadi kan. So kalau y components, kita hanya ada we only need to consider at this area, in which the forces is minus, sebab dia ke bawah kan. Kalau kita tengok sini, dia ke bawah lah kan. So minus P2A2 sin theta. Okay, sama juga on the left hand side kita ada m dot v2 sin theta. Okay, and then we rearrange, we will have the value for fy. Okay, now we already have both equation in x and y component. Okay, fx and fy. So apa dia cakap kat sini, where mass flow rate through the expander. Okay, ini m dot dia tertinggal ni. Okay, analytically it can be expressed as m dot rho A1 B1 and rho A2 B2 lah. Yang ni biasalah continuity if let's say kita consider the flow is incompressible kan. What mass flow rate in must be equal to mass flow rate at the outlet. Okay, so this slide tak ada apa-apa, dia just nak mention pasal atmospheric pressure which are acting on the expander, and then we also based according to the Newton's third law, the expander will experience the forces Rx and Ry in both x and y direction, in which equivalent to minus resultant in x and y. Yang ni macam saya explain tadilah, yang mana penting kan benda ni. Alright, okay, dia nak support di control volume tu. Okay, so okay, next kita akan go through some examples lah, sebab dekat sini too much theoretical part kan. So saya rasa it's better if let's say we go through few examples, and then it would be much easier for you to understand the concept of applying these momentum equations. Lagi senang lah. Okay. Okay, now we continue with a few examples. Examples related to momentum equations. Okay, and its applications. Okay, so this is the questions. The water gauge pressure of 350 kilopascal flows with a velocity of 5 meter per second. Okay, dia masuk ke control volume with 5 meter per second through a right angle band that has a uniform diameter of 250 mm. So means that the diameter adalah uniform dekat inlet dengan outlet lah. Okay, the band lies on the horizontal plane. Okay, and water enters from west and leaves toward the north. Okay, assuming that there will be no drop in pressure. Kalau no drop in pressure means that P1 is equals to P2 lah. Okay, what is the magnitude? Magnitude and direction of the force acting on the band. Okay, so maksud dia, apa yang dia nak actually adalah dia nak dapatkan what is the magnitude, this Fx dengan Fy and its resultant lah. Okay, Fy F resultant, okay, yang dikenakan ke atas this control volume, and the direction, the angle as well. Okay, the concept is similar macam yang contoh yang saya tunjuk sebelum ni, cuma yang ni dalam bentuk soalan. Okay, so how to solve this question? Actually biar saya delete dulu sekejap macam mana nak buat ni. Okay, home, and then okay, so susah sikit kalau nak refer to yang ni. So kita delete semua ni dulu. Okay, yang ni biarlah. Okay, so yang ni pun saya tarik ke sini sikit. Okay, okay, ni delete dulu. Okay, so macam mana kita nak dapatkan the value of this Fy, Fs dengan F resultant dia dengan theta? So whatever it is, kita guna pakai apa yang kita tahu dulu. Contohnya kita tahu this is the basic equation of momentum equation, in which total forces is equals to rate of change of momentum kan. So V2 minus V1 ataupun equivalent to rho Q V2 minus V1, ataupun equals to Q kita ganti equals to A times V, V2 V1 minus V1. Okay, so this is the most important lah. So first of all, apa daripada nilai yang diberi ni, kita boleh dapatkan the flow rate, the volume flow rate, volume flow rate, which is Q equals to A times V. Okay, A, area of sini diberi diameter dia sama dengan berapa? 250 mm. So the radius is 125 lah mm. So sini dengan sini sama. Okay, 125 mm. Okay, so what else dia cakap? No drop in pressure means that P1 and P2 pun sama, equivalent to 350 kilopascal. So based on the volume flow rate, kita boleh dapatkan value of volume flow rate equals to 0.245 meter cube per second. And then apa kita nak kena buat? Kita nak kena dapatkan Fx dengan Fy. So macam mana nak dapatkan Fx? So kita guna this equation. So belah kiri adalah total forces kan. So kalau kita tengok dekat sini, kita anggap ke kanan adalah positif Okay, so ke kanan of positif untuk X punya komponen So kita kat sini kita ada P kan, due to pressure P1 times A1. Okay, tapi since Fx resultant dia ke arah sini, kita kena tulis minus Fx equals to volume flow rate, rate of momentum lah, V2x minus V1x kan. Okay, so this is also equivalent to rho AV V2x minus V1x. Okay, kat sini kita tengok V2x is actually non-existent sebab dekat outlet, dekat position 2 ni, velocity hanya pada y direction. So V2x tak ada sebenarnya. So dia tinggal benda ni je. So macam mana kita nak dapatkan Fx? So negative Fx equals to negative P1 A1 plus rho A V times V. V ni V1 lah. Okay, since V1 is Vx kan. Okay, so tak apa, kita tulis V1 sahaja. Okay, so Fx in the end equivalent to P1 A1 minus rho A V1 square lah. Sekejap, kat sini saya tertinggal sini sebenarnya negatif V1 So tak boleh, sebab 0 minus V1 kan. So jadi minus V1. Okay, minus V1 ataupun equivalent to P1 A1. Jadi kita nak tu, baru kita darabkan balik jadi plus rho A V1 square. Okay, kat sini kita replace ganti nilai. So P1 equals to 350 kilopascal. So 350 000 area is pi r square. Pi r dia jadi 0.125 square times sekejap. Okay, alright. Plus density is 1000 lah. Density of water Okay, times A dia yang ni balik 0.125 square times V square kan. So 5 square. Okay, so kat sini akan dapat 17180.6, and then kat belakang akan dapat minus 1227.2. Okay, alright. And then kita akan dapat in the end around 18407.8 Newton ataupun equivalent to 18.41 kilonewton. Alright, so kita dah settle bahagian Fx. Okay, tak muat ni, saya kena top up sekejap. Insert for new slide. Okay, so next kita kena cari F2 pula kan. Dari sini saya nak dapatkan F2. So F2 macam mana nak dapat? So F2 usually kita anggap ke atas lah, positif Okay, so kalau kita tengok dekat sini, dekat bahagian asal F2, FY, sorry FY kan, untuk FY, bahagian FY, apa yang exist FY adalah dekat bahagian outlet sini So kita ada minus P2A2. Sebab apa minus? Sebab saya dah mention kan, pressure is always reacting towards the control volume. So kat atas pressure dia punya arrow ke bawah. So since kita dah letak arrow kat atas positif, so since dia ke bawah, so dia jadi minus P2A2 plus FY, sebab FY kat atas kan. Okay, equivalent to ini samalah belah kanan, rho AV V2Y minus V1Y. Okay, however V1Y dekat inlet tak exist kan, sebab dia horizontal kan, sama case macam tadi. So kita boleh cancel out yang tu. So in the end kita boleh dapat Fy is actually equals to P2A2 plus rho AV V2Y sahaja. Okay, yang ni also equivalent to kita ganti balik tadi 350,000, that is the pressure times, okay, area dia samalah kat sini dengan kat sini kan, sebab dia kata uniform diameter. Okay, dekat inlet dengan outlet, so area kat sini sama. So dia adalah pi kali 0.125 square, okay, plus density is 1000. Okay, area sama 0.125 square. Okay, so V, yang ni V2 sama dengan berapa? Not given kan, tapi kita tahu from continuity, saya ambil pen kali lain sikit. From continuity dia kata apa? Q equals to A1 V1 equals to A2 V2 kan. But since A1 dengan A2 sama, V1 is the inlet, V2 would be equals to V1 juga. That is why dekat sini kita guna sama juga, V2 is 5 Alright, so yang ni kita akan dapat, kalau kita selesaikan, kita akan dapat value dia sama macam tadi, 18.41 kN. Okay, so kita dah dapat answer the first question, which is the magnitude of X and Y. Tapi tak selesai lagi. So the resultant is actually 18.41 squared plus 18.41 square root kan, ataupun yang ni lah actually Fx squared plus Fy squared square root Okay, so yang ni, if let's say you guys ganti, you guys akan dapat equivalent to around 26.0 kN lah. Okay, and then how about the second question? It asks for the direction. Kita guna theta equals to tan minus 1 Fy over Fx. So kita akan dapat tan minus 1, ni sama juga sebenarnya, 18.41 over 18.41. So dia akan jadi tan theta equal tan minus 1 which is equivalent to 45 degree. That is why actually dekat sini Fx dengan Fy dia sama, dan dia punya angle tu adalah 45 degree dia punya direction dia. Okay, okay, and now we proceed with the second question. Actually this question is lebih kurang je, cumanya yang berbeza dia bentuk control volume dia a bit different Okay, so a reducing right angle dia right angle juga right angle band lies in a horizontal plane. Okay, water enters from the west with the 3 meter per second. So V1 dia masuk kat sini dengan 3 meter per second, and a pressure of P1 equivalent to 30 kilopascal. Okay, and it lift to the north ke atas. Okay, the diameter at the entrance is diameter 1 is 500 millimeter, and at the exit is kecil sikit, diameter 2 equals to 400 mm, in which equivalent to R2 equals to 200 mm, R1 equals to 250 mm. Okay, neglecting any friction loss. Okay, find the magnitude and direction of the resultant force. So konsep soalan dia sama juga tadi. Dia nak dapatkan Fx and then Fy, lepas tu dapatkan F resultant dia, lepas tu dapatkan dia punya theta. Okay, so based on this, apa yang kita boleh dapat, apa yang kita boleh cari dulu, kan? So based on continuity, actually kita boleh dapatkan this value dulu, V2 yang dia keluar dekat outlet ni, kan? Based on continuity, diganti A1 B1 equals to A2 B2. Okay, and then dia replace, dia akan dapat. Saya tak payah tunjuk satu persatu untuk this question sebab almost similar. So kita akan dapat around 4.69 meter per second. So yang ni 4.69 meter per second. And then what else? So kita dah dapat ni, kita dah ada ni pula. Maksud dia P dekat 2 pula. Macam mana nak dapat P dekat 2? P dekat 2 actually boleh kita dapat daripada energy equation ataupun Bernoulli. Okay, that is why bila kita kata fluid mechanics ni, kita kena relate sebanyak daripada continuity kepada Bernoulli dan juga kepada momentum equation. Semua interrelated in order to solve a fluid flow related problems. So based on this Bernoulli ingat lagi tak rumus dia macam mana? Ingat kan? P1 over rho 1g plus V1 square over 2g. Actually ada satu lagi, plus Z equal to P2 over rho g plus V2 squared over 2g. Okay, plus Z. Okay, since ini adalah apa, right angle plane ni lies horizontal, so yang ni tak ada lah. Okay, so kita ganti, kita dah ada actually value of P1, kita ada ini P1, kita ada P2, kita ada P2, kita ada. Dah cari dah semua ni kan? No, V2 adalah benda yang kita nak cari. Maaf V2 adalah benda yang kita nak cari. So we would like to get this value. We want to find this value. Sorry, hilang pula itu. Okay, yang ni semua constant sebab dia water kan. That's why kita replace, kita akan dapat P2 is actually equivalent to 23.5 kilonewton per meter squared. So yang ni sama dengan 25 kilonewton per meter squared. Sama dengan kilopascal lah sebenarnya. 25 kilopascal dekat P2 ataupun 25 kilopascal. And sebab dekat inlet kita pakai 30 kilopascal, yang ni adalah 23.5 kilopascal. Okay, so kita dah dapat all the important information dekat inlet dengan dekat outlet. So next, macam mana kita nak proceed? Kita proceed dengan momentum equations terus. Momentum equations yang mana apa cakap, total force equals to m rate of change of momentum kan, P2 minus V1. This is a very powerful equations yang mana korang perlu tahulah. Okay, and then based on this you need to find all the forces related, all the rate of change of momentum dekat V2 and V1 kan. And then you will get, saya tak perlulah tunjuk satu-satu sebab konsep dia actually sama dengan yang tadi ni sebab condition dia sama, yang bezanya hanya size sahaja. Okay, so you guys go through and then you will get the value of Fx will be equivalent to 7.66 kilonewton, and for Fy you will get 5.72 kilonewton. And so based on both information, dan kita dapat Fx dengan Fy, kita dapatkan resultant dia which is equivalent to 9.56 kilonewton. And then macam biasa nak dapatkan theta dia equivalent to tan minus 1, Fx dia, Fy dia adalah 5.72 over 7.66, which is also equal to, sekejap saya try calculator, supposedly kita akan dapat 5.72 bahagi 7.66, okay, 36.75 degree ataupun 36.8 degree. Okay, so senang je soalan dia. So yang membezakannya maybe dari segi macam mana kita nak dapatkan input-input penting dulu dekat inlet dengan kat outlet, dan assumption apa yang dia guna pakai. Contoh macam kat sini, apa yang kita perlu cari dulu, sebelum kita proceed dengan momentum equation kan, sebelum kita proceed dengan this equation. So in order to get all the information here, macam biasa you need to refer to the Bernoulli dan juga continuity. Yang ni continuity kan, so semua interrelated. Okay, next kita tengok lagi satu contoh soalan. Cumanya this time around the water flow through a reducing 180 degree bend, kan? Dia 180 The bend is shown in plan. Determine the magnitude and the force exerted, and so yang ni dia nak cari magnitude and force exerted in the bend direction. So dia nak cari kat sini, kan? Berapa nilai magnitude dia. Okay, so macam mana nak cari dekat sini? Assume energy losses to be negligible, and dia tak ada losses. So given that V3 V1 yang ni VA lah, ni position A equals 3 meter per second, and then P A equals to 20 kilopascal, cross sectional area at A 1 meter squared, tapi cross sectional area kat sini je berlainan. So apa yang kita perlu cari sebenarnya, kita perlu cari apa yang tak ada kat sini. VB equals to berapa dengan PB equals to berapa, kan? So sama konsep macam tadi, based on continuity kita boleh dapatkan VB which is 6 meter per second. Based on energy or Bernoulli, kita boleh dapatkan this PB berapa. PB equals to 6.5 kilopascal. Nampak? Dia punya trend sama je sebenarnya. Kita dapatkan all the information dulu, and then semua dah ada, baru kita proceed dengan the momentum equation. So based on this, kita boleh dapatkan the value of force exerted on the band, which is this one, FRS ni. Okay, so kalau kita refer balik, kita guna ni lah, sebab kita consider Y positif, positif sini. Okay, so PA yang bergerak kat atas control volume dia ke sini, sini pun yang bergerak kat atas control volume sebenarnya ke sini. Pressure kan, pressure mesti kat atas control volume kan. That's why sini positif, tapi sini negatif sebab dia ke arah sini. Okay, and then equivalent to rho Q VB minus VA, and then VB pun kita dah tahu apa, VA kita dah tahu apa, Q equals to apa, A times V kan. Alright, yang ni constant lah, 1000. So kita replace, kita akan dapat the value of the force exerted on the band is equivalent to 50.25 kilonewton. Okay, alright, kita continue dengan next application of a momentum equation, and for this time around kita akan fokus on the force on a nozzle at the outlet of a pipe. So because the fluid is contracted at the nozzle, so this is the image lah. If let's say those question related to the force of on a nozzle at the outlet of pipe. So because the fluid is contracted, and kan kita nampak kalau satu nozzle tu fluid is contracted at the nozzle, forces are induced in the nozzle, of course, kan, sebab dia contract kan. So anything holding the nozzle, for example a fireman kan, waktu dia buat kerja, must be strong enough to withstand these forces. So contohnya apa tu, fireman lah, dia nak selesaikan tugas dia kan, dia nak siram apa, if let's say ada kebakaran kan. That is why forces yang dikenakan ke atas nozzle tu sebenarnya besar. Okay, sometimes it requires few firemen to hold the nozzle together kan, in order to make sure that they can withstand the forces, okay, on the nozzle kan. Alright, so this is apa benda penting that we need to know the forces untuk kita withstand dekat bahagian nozzle tu. So the analysis takes the same procedure as before. So in order to solve this kind of problem, kita guna procedure yang sama juga. Firstly, apa kita buat? Macam biasa, kita kena lukis the control volume. Okay, alright, control volume area of the nozzle, as well as we need to define the axis as well. Okay, which one is positive, which one is negative, and then kita ada input lah dekat ni dengan dekat nozzle. Okay, bahagian depan dengan bahagian belakang. So how to calculate? Kita guna rumus macam biasa, rumus apa, momentum equation, and total forces equals to the rate of change of momentum, in which ini juga sama dengan rho Q lah kan, mass flow rate equals to density times the volume flow rate times change in velocity at U2 and U1. Okay, so this is the theory lah, mana kita akan guna the momentum equation. But as I've mentioned previously, bila kita cakap pasal solving a fluid flow problems, kita mesti kena relate dengan rumus-rumus lain, in which kita kena refer to the continuity, refer to juga Bernoulli, and then kita akan refer to momentum equation. And I suppose you guys masih ingat lagi kan, dalam apa slide saya yang sebelum ni, in which saya terangkan what is the the continuity equations related, and also Bernoulli, and also the slides for momentum. Okay, so apa total forces yang dikenakan ke atas nozzle tu, kalau kita tengok dekat sini kan, actually kat sini dia dah simplified. Kita refer tu balik yang belakang ni, Ft equals to mass flow rate times U2 minus U1 kan. Okay, so ini juga actually rho Q. Okay, kat sini U2 and U1 ni sebenarnya dia guna continuity kan, dia ada refer to continuity juga kan. So dia replace lah U2 and U1. So maksudnya if let's say U2 equals to U1 A1 over A2, and U1 equals to U2 A2 over A1, and cuba kita replace balik kat situ. So U2 akan jadi U1 A1 over A2. Okay, this one minus U2 A2 over A1. Okay, so kat sini sebenarnya kita tahu what is this? This is Q kan. So kita boleh keluarkan dia. So dia akan jadi rho Q squared 1 over A2 minus 1 over A1. That's why kita dapat Ft equals to this. Okay, alright. And then kita juga akan apply Bernoulli equations untuk kita calculate the pressure forces. Okay, so you guys still remember tak macam mana nak kira the Bernoulli equations. So yang ni kena familiar kan So kita tahu P1 over rho G plus V1 squared over 2G plus Z1 equals to P2 over rho G plus V2 squared over 2G plus Z2. Okay, but since kita consider kalau cases like this, the elevation tak ada, so Z1 equals to Z2 So this one can be considered, can be cancelled out. And then one more important thing is that kita dapat tahu P2 equals to 0. Sebab apa? Sebab P2 is out at the atmosphere. Okay, so P2 is equals to 0. So this is also important untuk kita cancel. Okay, so bila kita selesaikan ni, kita akan dapat P1 equals to this. Okay, so untuk pressure force, sebab ini adalah pressure. Okay, we use the Bernoulli equation to find the pressure, and then to calculate the pressure force, kita kena guna F equals to PA lah, kan? So that's why kita guna rumus yang kita dapat ni, kita darab dengan A. Okay, which is the A1 lah. Okay, and then kita dapat this. Okay, so kalau kita tengok dekat sini, kita dah dapat calculate the total force dengan pressure force. Okay, and then actually, if let's say you guys still remember, total force is equivalent to the resultant force plus the body force plus the pressure force. Okay, but the body force is due to gravity, in which refer to y direction. Tapi untuk this case, kita hanya considering the x direction, sebab dia semua ke x direction kita tak consider y direction. That is why kita boleh consider FB equals to 0. So ini tak ada. So kita boleh dapat the resultant force, in which the resultant force equals to the total force minus the pressure force, in which kita dah calculate siap-siap dah dekat atas ni. Saya highlight sikit green color, which is this is the total force. Ini ini juga, dan juga di pressure force, which is this one. Okay, ini. So to conclude, the fireman must resist the force which is minus FR, kan? FR is the force untuk kita control di nozzle. Tapi untuk fireman to resist the force is the opposite, untuk control dia, kan? The force is like that. So in order to control it, the reaction force must be negative the resultant force. Okay, so yang ni kena take note. Okay, and now kita pergi ke contoh soalan. Contoh soalan. So a nozzle has an exit diameter of 15 mm. Okay, and discharge water into the atmosphere. Okay, so bila tahulah, bila kita kata atmosphere, P2 equals to 0 lah, kan? So what else dia kata? The gauge pressure behind the nozzle is 400 kPa. Okay, so kita ada nozzle. Okay, P2 equals to 0, P1 equals to 400 kPa kali 10^3 lah. Alright, so exit diameter dekat sini equals to 15 times 10 to the power of minus 3 mm, kan? Okay, what else dia cakap? The coefficient of velocity. Okay, lama tak jumpa, kan? The coefficient of velocity is CV. CV is given 0.98, and there is no contraction of the jet. Okay, the jet hits a stationary flat plate normal to its direction. Okay, ini consider macam dia hit satu wall dekat sini, yang mana normal to the direction. Okay, determine. Okay, ni soalan dia. The question asks to determine the force on the plate. Okay, alright. So force yang dikenakan ke atas plate ni. So given the density of the water is 1000 kg per meter cube, and assume that the velocity approaching the nozzle is negligible. So kita consider V1 dia equals to 0. Okay, so macam mana kita nak V2 equals to 0. Sorry, V2 equals to 0. Okay, sebab dekat sini kan. Okay, so sini V1, sini V2 kan. So kita consider dekat situ equals to 0 So how do we start? Kita kena start. Actually kalau dekat sini saya tukar lain. So apa yang kita kena tahu, kita tahu P2, kita tahu P1, kita tahu V2. So kita kena cari V1. How to find V1? So V1 can actually be obtained by using Bernoulli. Ingat tak rumus Bernoulli? Kita kena tulis banyak kali supaya kita ingat. V1 over rho G plus V1 squared over 2G. Sebab kita tak consider elevation So Z punya parts kita cancel out siap-siap. So P2 over rho G plus V2 squared over 2G. Okay, so apa yang kita tahu adalah this part is 0 This part is 0. Okay, so lepas tu atmospheric pressure pun kita consider 0 lah, P2 So kita tahu V1 squared over 2G equals to, tak apa, P2 ni kita tak consider 0 lagi, kita biar dulu. Okay, so sebab yang ni kita nak biar dalam equation dulu So V1 squared equals to P2 minus P1 over rho G. Okay, so V1 squared equals to delta P P2 minus P1 is delta P lah, over rho G times 2G. So ni cancel out. So actually kita akan dapat apa? Delta P 2 delta P over rho. Okay, V1 squared. Okay, ataupun kat sini kita cancel terus lah. Squared kat kiri, kita darab 1/2 belah kanan. Okay, since the questions give the coefficient of velocity, kita kena consider dekat sini ada coefficient of velocity, and then from this equation actually kita boleh find the V1 kan, sama tak? CV equals to 2 delta P over rho square root of 2 delta P over density. Okay, so this is given, this is 2 times 400 kPa over the density 1000, kita dapat V1 punya value. Okay, so macam mana kita nak kira this determine the force on the plate. Okay, so kita boleh guna rumus this FR. FR is actually equals to M dot P2 minus V1. Tapi since this correction factor is not given, kita cancel out lah, ataupun kita consider equals to 1 lah. Dia tak ada correction. Okay, beta equals to 1 means dia tak ada corrections. So kita tahu kalau kat sini dia akan jadi, since V2 equals to 0 juga, dia akan jadi minus V1. Betul tak? Okay, so macam mana kita nak dapatkan this value? This value kita tahu mass flow rate apa? Mass flow rate equals to rho AV, and then A equals to the nozzle exit area. This is all given kan, apa, 15 mm. So by using the pi r squared, kita akan dapat this is the area, and then kita replace kat sini, this is given, this is apa yang kita dapat dekat sini, kita akan dapat the mass flow rate. Lepas tu kita ganti mass flow rate dekat sini, and V1 dekat sini, kita akan dapat this value. Tapi kat sini negatif. Tapi since the force the force on the plate kita adalah the reaction so kita tahu macam case tadi kan, Fr equals to negative F. So this is negative F. So force negative R, sorry. So R is actually m dot V1. So kita akan dapat the value, the force that is exerted on the vane is 135.8 Newton. Okay, so this is example lah. So kalau kita tengok dekat sini kan, soalan dia simple je, tapi you need to apply all the equation yang kita dah belajar sebelum ni kan, especially di Bernoulli and also momentum equation, and sometimes we also apply the continuity punya equation. Okay, next kita pergi ke next contoh soalan juga. Alright, so kita tengok soalan ni. Water is accelerated by a nozzle to an average speed of 20 meter per second. Okay, dia give 20 meter per second. 20 meter per second is dekat sini lah. Okay, and strike a stationary vertical plate at the rate of 10 kg per second, given the mass flow rate equals to 10 kg per second. Okay, with a normal velocity of 20 meter per second. Okay, after the strike, the water stream splatters off in all directions. So waktu dia kat sini, dia splatter off. Contoh kalau kat sini apa yang kita nampak, dia ke atas dan ke bawah kan. So the question asks, determine the force needed to prevent the plate from moving horizontally due to the water stream. Kan? Kalau kita kat sini, kita tahu the resultant force actually ke sini. Okay, so macam mana kita nak make sure plate ni tak akan bergerak kan? Determine the force needed to prevent the plate from moving horizontally due to the water stream. So kita kena make sure this Fr is enough in order to make sure water jet ni tak akan bergerakkan dia. Okay, so kita anggap V2 ni, kita tak nak V2 equals to 0 kan. If not, V2 ni bergerak, dia dah tak capai soalan dia ni lah. Okay, so macam kita tahu kan, Fr equals to apa? M dot, since beta tak ada, tak apa, kita tulis beta juga lah. Ke sana positif kita anggap. So V2 minus V1. Okay, beta. So kita anggap correction factor sama dengan 1 lah. Okay, so since V2 tak ada, so kita cancel out situ. Okay, so dia jadi M dot minus V1. Okay, so tapi Fr belah sini kan, so dia adalah negatif Fr. So negatif Fr sama dengan itu. So Fr sama dengan M dot V1 kan. Negatif kat sini, dia negatif sebab kita dah set ke sana positif kan. Okay, so given the mass flow rate is equivalent to 10 kg per second time V1 is 20, so kita akan dapat the force needed to prevent the plate from moving adalah 200 Newton. Okay, sama kan. Okay, so next kita proceed dengan the third cases related to the application of momentum, which is the impact of a jet on a surface, on a plane surface. Kalau kita tengok dekat sini gambar ni kan, dia ada two cases in which sama ada impact tu adalah normal to the plate ataupun incline to the incline plate kan. So kalau normal senanglah kita dapat tengok kan. Kalau incline dia ada this theta yang mana dia akan create, okay, based on this perpendicular from the plate surface. Okay, dia akan create this theta angle. Okay, so if let's say cases like this, how we are going to process to solve a question related to these problems. So kita akan go through satu persatu. Firstly kita go to the theory first. So impact of a jet on a plane surface. Sebab kalau macam ni kita consider macam case study lah, kita hanya consider in x direction. What happen in x direction. Okay. Okay, sekejap. Okay. Alright. So the general term of the jet velocity component normal to the plate can be written as v minus u cos theta. So kita ada this, kita ada this, kita ada this theta. Okay, this is the normal term lah. Okay, so the mass flow entering the control volume is rho a b tolak u. Yang ni samalah macam yang kita belajar sebelum ni kan. Kita ada rho a b tolak u. Okay, ini tolak ini Okay, so but if the plate is stationary, means that u ni tak bergerak. So kita kena cancel out this u. That's why kita hanya tinggal mass, the mass flow rate equals to rho av. Okay, so kita consider yang ni equals to 0. Okay, so thus the rate of change of momentum normal to the plate will be equal to, kita tahu total forces kalau ke arah sana equals to m dot v tolak u kan. So kita tahu dah this mass flow rate equals to rho a v tolak u kan, based on yang ni kan. Kita consider ini, saya padam dulu. Mass flow entering the control volume adalah this one. Okay, rho a v tolak u. Lepas tu kita darab v tolak u lagi, which is this one. So this one is this one, and then darab belakang v tolak u. And then kita ada cos theta lah kalau cases di mana the jet impact on an inclined surface, inclined plate. Okay, that is why kita akan dapat rate of change of momentum equals to rho a in bracket v minus u in bracket v minus u cos theta. And sebab kita consider x direction sahaja. Okay, right. So if let's say the case stated that the plate is stationary and inclined, means that for this case u equals to 0. So bila u equals to 0, kita cancel out ni, kita akan tinggal apa? Rho a v times v squared cos theta. That's why kita dapat ni. Okay, so yang tu if let's say plate is stationary and inclined. But if the plate is both stationary and perpendicular, perpendicular means that the impact is like this lah. And untuk yang case satu ni, case yang ni Okay, so if let's say like that, kita just remove this cos theta. Dia stationary dah. Stationary meaning tak ada u kan. Lepas tu dia perpendicular, means that dia tak ada cos theta. So dia akan jadi rho AB squared sahaja. So daripada sini jadi sini sahaja, dia remove this cos theta. So dapat beza these two cases. Alright. Okay, so kita pergi kepada contoh soalan terus lah kiranya. Okay, kalau kita tengok kat sini, dia soalan, a jet of water from a fixed nozzle has a diameter of 25. Okay, dia bagi diameter 25 mm and strikes a flat plate at an angle U of 30 degree, and dia bagi this angle equals to 30 degree. Okay, so the velocity of the jet is 5 meter per second. Okay, it's given this V equals to 5 meter per second. Okay, diameter of the nozzle given tadi, saya tulis balik 25 millimeter. Okay, and the surface of the plate can be assumed frictionless. Kan, dia kata apa? Ini penting The surface of the plate can be assumed frictionless, means that dia tak ada shear stress atas this plate. Okay, so the question asks to find the force exerted normal to the plate if the plate is stationary. Means that kalau the plate is stationary, U equals to 0 lah, and ini tak bergerak. So, and Allah, sekejap, ada dua pula B kat sini. Sorry. Okay, and yang kedua, if the plate is moving with a velocity of 2 meter per second. Kan? So, soalan adalah force ke atas plate tu if let's say the plate is tak bergerak, and if let's say the plate is moving at 2 meter per second. So, how are we going to solve this kind of questions? Okay, so firstly we need to know lah, yang ni adalah few theory yang we need to take note if let's say we would like to solve this kind of questions. For each case, the control volume is fixed relative to plate. Since we wish to find the force exerted on the normal to the plate, the x direction is chosen perpendicular to the surface of the plate. That is why the x is perpendicular to the surface of the plate. This okay, and a force exerted by fluid on the x direction is ni seperti yang kita tahulah sebelum ni, and this is very important. The total force equals to the resultant force plus the body force plus the pressure force equals to the mass flow rate out minus in x direction. So this is the important momentum equation, and total forces equals to the rate of change of momentum. Okay, so the total forces is actually equivalent to the reaction force jugalah, and sama ada cuma kena tengok dia punya arah, and usually Ft equals to minus R lah, and vice versa. Okay, so however usually the gravity force Fb is negligible, kan? Sebab apa? Sebab gravity kan mg is due to gravity. So ini selalu kita consider if let's say in y direction. That's why usually kita cancel out this part. Okay, and the second part is that the jet is assumed to be atmospheric pressure throughout. So kita consider, sebab dia kan lepas jet nozzle tu kan dia keluar ke atmosphere kan, so kita consider this one is also Fp is also negligible. Okay, or zero lah. So kita tahu kat sini ini sahaja yang tinggal. So the reaction force equals to the opposite the resultant force. Okay, so kita akan dapat this equation okay, minus mass flow rate V out minus V in, ataupun mass flow rate V in minus V out. Okay, in which V in and V out are measured relative to the control volume. Okay, so kita dah take note on this all theory. Okay, so kita move on to the question. The question yang asked tadi kan, force exerted normal to the plate if plate is stationary and if let's say the plate is moving. Okay, so firstly kita consider if the plate is stationary. So if the plate is stationary, mass per unit time of the fluid entering the control wheel must be equal to mass per unit time leaving the nozzle. Yang ni seperti semua tahulah. So untuk case ni actually kita dah go through tadi kan, in which kita boleh guna this equation kan. The plate is stationary and inclined. Okay, so kita guna rho AV this rho A V squared cos theta. Sama tak kan? Rho AV yang ni banyak sangat. Case dia adalah sama dengan yang ni, rho AV squared cos theta kan. The plate is stationary means that u equals to 0 and it is inclined. So straight away kita boleh guna this equation. Okay, so next kita just replace lah. The density is 1000 and then is given the the area of the nozzle pi r squared times 5 is the velocity and also 30 degree. Yang ni darab bukan x Okay, so kita akan dapat the forces the forces exerted normal to the plate if the plate is stationary will be equal to 10.63 Newton kan, if let's say the plate is stationary. Okay, and if let's say the plate is moving, the plate is moving sebanyak berapa tadi soalan dia? 2 meter per second. 2 meter per second. So macam mana kita nak solve? Kalau kita refer tu balik soalan yang kita buat tadi tu, kita boleh guna rho A bukan yang ni. Kita guna this one. So kat sini sebenarnya dia ada 3 equation Sekejap saya padam balik, banyak sangat saya tulis kat sini. Okay, so kita kena tengok balik lah sama ada kita guna ni, ini atau ini. Okay, ini untuk case if let's say dia bergerak, plate bergerak dan juga dia incline plate. Yang ni if let's say dia incline plate tapi plate tu tak bergerak. Yang ni pula plate tu tak bergerak dan juga perpendicular. So for case the question tadi dia ask untuk if let's say the plate bergerak dan ada incline, so kita akan guna this equation. That is why kita guna this kan, macam tadi rho A V tolak U V tolak U cos theta kan. So kita tahu the density ni semua so on, kita ganti. Cuma dekat sini kita ada speed of plate tu yang bergerak 2 meter per second kan. Kita ganti, kita akan dapat the forces exerted normal to the plate is equal to 3.83 Newton. Okay, nampak tak perbezaan antara this one and this one? Yang mana rumus yang diguna pakai adalah berbeza bergantung kepada keadaan plate tu sendirilah. Sama ada dia incline ke, dia parallel ke, sama ada plate tu bergerak ke atau tak bergerak. Okay, okay, kita continue with basically the last part of this chapter, in which is the application of momentum equations on Pelton wheel. Pelton wheel Okay, so what is a Pelton wheel? Pelton wheel is a water impulse turbine. So it was actually invented by this guy here, Lester Alan Pelton, in the 1870s. And the Pelton wheel extracts energy from the impulse of a moving water. Okay, so basically this is dia punya idea lah, macam mana this Pelton wheel function. So in basically dia ada satu jet nozzle here, water jet, and then this water jet dia akan tembak this usually water this fluid ke atas this so called the spoon shaped buckets ini this is the consider a turbine. So dia akan tembak sini and then benda ni akan berputar. Okay, this so called the impulse of a moving water akan extract energy and akan generate energy lah. Basically this is the concept of a Pelton wheel. Actually this dekat setiap satu bucket here dia ada bentuk something like this, yang mana U1 is actually the water jet yang hit the bucket and then dia akan pecah kepada dua, satu ke atas, satu ke bawah. This is the basic concept lah of how the function of Pelton wheel. Okay, so Pelton's pedal geometry was designed so that when the rim runs at half the speed of the water jet, the water leaves the wheel with very little speed and extracting almost all of its energy and allowing for a very efficient turbine. This is the geometry of the pedal itself or the bucket, and kenapa this kind of geometry is chosen. And then this is basically the construction of the Pelton wheel. Okay, dia ada dam yang ada air yang akan masuk ke nozzle. Nozzle ni akan tembak this bucket untuk this Pelton wheel function. Okay, so nozzles will direct forceful the streams of water against a series of spoon-shaped buckets mounted around the edge of a wheel. So these nozzles ni dia akan tembak lah bucket-bucket ni yang di sekitar runner ni untuk dia bergerak lah Okay, so when the water jet contacts the bucket, the water exerts pressure on the bucket and the water is decelerated and it does a U-turn. U-turn ni macam yang ni lah tadi bila dia hits the bucket, dia akan create U-turn and flows out the outer side of the bucket at a low velocity, and this will create some impulse that is working on the turbine. And this is also an important part in which for a maximum power and efficiency, the turbine system is designed such that the water jet velocity is twice the velocity of the bucket. Okay, so untuk maximum power, turbine system is designed such that the water jet yang dikenakan ke atas this bucket is twice the velocity of the bucket itself. Okay, and this is mostly the application lah. So yang ni boleh baca sendirilah kan. And then apa benda penting kat sini ada Pelton wheels are the preferred turbine for hydropower generation lah. Okay, so yang lain-lain ni you guys can read by yourself. Okay, so this is how Pelton wheel looks like in real life So this is some schematic diagram macam mana Pelton wheel tu sebenarnya terbentuk. Sebenarnya kat sini dia ada dam lah, dam of water water, and then dia ada nozzle ni tembak ke bucket ni, and then this turbine akan berpusing, and then water pun akan masuk kat sini, dan dia ada jugalah drain untuk drain air, access air lah ke bawah. So this is apa orang cakap overview of the setup of the Pelton wheel. Okay, okay, this is on the Pelton wheel blade the blade itself, and the arrangement of a Pelton wheel is shown in the figure. So macam yang saya tunjuk tadi this is the kind of shape of the Pelton wheel punya blade lah. Okay, a narrow jet usually of water is fired at blades which stick out around the periphery of a large metal disc, and the shape of each of these blades is such that as the jet hits the blade, it splits into two, it splits into two, which with half of the water will be diverted to one side, and the other one will be diverted on the other side. Okay, the splitting of the jet is beneficially to the turbine mounting and causes equal opposite forces. So it means that this shape dia akan bagi advantage jugalah kepada mounting of the turbine itself, in which dia akan elakkan external punya forces to be involved lah. Okay, yang mana dia akan lost the efficiency of the the turbine itself. Okay, so this is a more technical side on how Pelton wheel is working. Alright, so consider a Pelton wheel rotating in an anti-clockwise. So dia bergerak anti-clockwise with an angular velocity of omega due to the combined action of an incident water jet. So that the incident water jet, so this is the nozzle so dia akan tembak kepada this, ni sebenarnya satu turbine lah. Okay, so ini yang dia consider kat sini as one satu bucket sahaja Okay, so apa yang dia nak cakap adalah Pelton wheel ni akan rotate due to this combine of incident water jet, which is V1, and also a clockwise resisting torque. Okay, so the velocity analysis will use a bucket on the Pelton wheel as a reference. So dia akan guna this untuk analysis of velocity. So untuk velocity analysis, dia guna velocity relative to bucket. So velocity of the incident jet relative to the bucket is given by, so this VR1 relative velocity equivalent to the velocity of the incident water jet minus the velocity of the bucket, in which also equals to V1 minus, kalau bucket velocity adalah omega R lah, and omega is the angular velocity times R. Okay, the radius of the Pelton wheel. Okay, yang ni kena take note this is a very important formula for you guys. Okay, alright. Next, nozzle flow coefficient. So ini adalah sub parts yang you guys need to know, so that later on kita akan guna pakai lah. Alright, untuk analysis of Pelton wheel. Okay, so the discharge through the nozzle from the inlet head is given by, kita tahu from momentum, the mass flow rate is equals to not the mass, the volume flow rate. Q dot is a volume flow rate is equals to A times V. Okay, in which V1 is actually equals to CV square root of 2GH. So yang ni sebenarnya kita dah dapat this equation from Bernoulli last time, flow from an orifice. So dia punya condition is lebih kurang sama kalau kita tengok kan. Nanti you go back to the slide where saya tunjuk pasal orifice function. Okay, how we adopt this Bernoulli equation, and hence kita akan dapat these equations. And then from here kita replace this V1 masuk sini. Okay, kita replace this one, and then kita dapat the volume flow rate is equals to A times CV square root of 2GH. Okay, so yang ni tak apa, ni kita dapat, kita tinggal tepi. So later on kita akan guna pakai. Okay, okay, next, bila kita kata Pelton wheel ni mestilah dia nak generate energy. So nak generate energy through the power output dia. So bila kita kata Pelton wheel, mesti penting untuk kita kira the power output dia. Okay, this is how we calculate the power output. Okay, so the force exerted on the bucket by the water jet is actually obtained by this Newton's second law, as the rate of change of momentum between the incident and emergent jets in plane of the wheel. So kita tahu total forces equals to mass flow rate times delta V. Okay, in which the mass flow rate is actually the volume flow rate times the density. Okay, based on yang ni lah. Okay, yang ni is the usual momentum equation yang kita dah go through few times lah. Okay, so next is the torque acting on the shaft of the Pelton wheel is then given by F time R, in which this F is actually this F. Okay, kita replace balik, masuk kat sini, kita akan dapat this equation. Yeah, the volume flow rate times density times change in velocity and times the radius. Okay, and then okay, so the power output is torque yang kita dapat tadi times omega. And torque kita dapat tadi apa? Torque kita dapat tadi adalah this one. Okay, this one times omega. Omega pula kita tahu, omega equals to U equals to omega R. Betul tak? So omega equals to U over R. So kita replace U over R here untuk omega. So kita cancel out R dengan R, kita akan dapat this, the final equations for the power output. Okay, tapi sebenarnya kita boleh simplify lagi this power output by substituting the value of the mass flow rate and delta V. Okay, the mass flow rate is ini yang kita dapatkan yang awal-awal tadi, the mass flow rate, and also delta V. Delta V is a bit complicated, but as for time being, you guys just accept lah yang delta V is equal to D. Dia ada cos disebabkan kalau kita tengok kan, dia ini yang velocity masuk, yang velocity keluar ni dia ada theta kan, dia ada value of theta yang mana kita kena consider direction bila kita consider the x component. Okay, alright, so kita dah tahu this is the equation for the power output. Okay, next, untuk kira efficiency is power output yang kita dapat tadi over the input hydraulic power. So yang tadi kita dapat tu adalah ni, tapi in order to find efficiency, kita kena kira this input hydraulic power. So the input hydraulic power is actually the product of inlet pressure times the flow rate. And the inlet pressure is rho GH lah, rho GH times the volume flow rate. So kita replace this one dekat bahagian bawah dengan this one, this one dekat bahagian atas ni, and then kita cancel out those related, and then kita dapat final efficiency equals to this, U times delta V over GH. Okay, delta V ni kita tak tukar ni lagi lah. Okay, tak apa, for time being kita guna ini sahaja dulu. So this is how we calculate efficiency. So nampak tak kat sini apa yang kita kena buat? First kita dapatkan apa tadi, kalau kita ni the volume flow rate, and then how to calculate the power output, and then in order to calculate the power input, kita kena dapatkan the input of hydraulic power. Lepas tu efficiency is the power output over the input hydraulic power, and then what else? Okay, so ini adalah untuk if let's say tak ada apa pun, dia just substitute delta V ke dalam ni. Okay, and also for a maximum power, macam yang saya cakap awal-awal tadi, saya rasa saya ada cakap dah dekat sini. Okay, for maximum power and efficiency, the turbine system is designed such that the water jet velocity is twice the velocity of the bucket, kan? So in order to achieve that is why kita ganti V1 equals to 2U, kan? So kita replace masuk dalam tu, end up kita akan dapat satu lagi efficiency punya equations. So basically tak ada beza pun dia ini dengan ini. Usually kalau ada soalan pun dia akan bagi yang related to apa yang parameter yang ada. Okay, so in the end kita kena tahulah this is the basic efficiency punya equations. Okay. Okay. The analysis takes the same procedure as before. Ini kalau kita consider macam mana kita nak kira forces forces in x and y direction. If let's say the inlet water jet hit the bucket. Okay, so procedure sama saja macam sebelum ni. Kita kena create the control volume and coordinate axis. So kalau kat sini kita consider y positif ke atas dan x positif ke kanan So and then kita ada juga this control volume. Okay, so in order to calculate the total force kita guna momentum equation lah macam biasa. Atau momentum equation, total forces equals to rate of change of momentum kan, V tolak U, in which this mass flow rate is also equals to density times the volume flow rate. Okay, so kita tahu, lepas tu kita replace kat sini. Lepas tu actually since U2, kalau kita tengok kat sini kita ada U1 yang mana yang hit tengah-tengah bahagian bucket tu. Lepas tu dia akan keluar ke atas dan ke bawah kan, U2 with an angle theta. Okay, so in x direction kan, kita consider first in x direction. Untuk U2 kita ada U2 cos theta lah kan, kita consider x component. And then kita ada atas dan bawah 1 dan 2. So maksud dia kita ada U2 cos theta and U2 cos theta. And then U2 cos theta ni positif sebab ke kanan positif kan, so dia pun bergerak ke kanan positif. And then minus U1 pula ke kiri since ke kiri value dia minus. Okay, so end up kita akan dapat total forces in x direction is equals to rho q in bracket U2 cos theta plus U1. And so in y direction on the other hand, since it is symmetrical kan, ke atas ke bawah, kita consider Fy in y direction, the total forces in y direction is equal to 0. Okay, so macam kita tahu kan sebelum ni, total forces equals to the resultant force plus body force plus the pressure force. However, in this case pressure force is 0 and body force is 0. The pressure force is 0 because kita consider the condition is at atmospheric pressure. And also since we are only considering the horizontal plane, so the body force is also neglected, equals to 0. And hence kita akan dapat the resultant force is equals to the total force, which is equals to rho q U2 cos theta plus U1. So sama macam yang kita dapat yang tadi ni. So total forces equals to the resultant force. And then if let's say we want to calculate the force exerted on the blade, it is actually the same magnitude of the resultant force or total force yang kita dapat tadi, but in opposite direction kan. So sebab dia exert the force, dia negative lah in direction. Okay, so now we go for an example related to the momentum equation. So to the Pelton wheel, so in these questions, a Pelton wheel vane directs a horizontal circular cross-sectional jet of water symmetrical with a diameter of 10 cm. Okay, dia bagi diameter dia 10 cm as indicated in the figure. The jet leave the nozzle with a velocity of 50 meter per second. Okay, this is given. And then determine the force exerted on the vane. So bila kita dia kata determine the force exerted on the vane, kita kena buat macam biasalah. Dia ada two components in which is fty and ftx, in x and y components. Okay, so firstly from the questions, given that the diameter of the circular cross sectional jet adalah 10, so kita tahu pi r square. Untuk dapatkan the cross sectional area, kita akan dapat 7.85 kali 10 kuasa negatif 3 meter square. And then what else, we need to find this u dekat sini u dekat sini is equals to this relative ni, velocity kat sini equals to this jet velocity minus the velocity of the vane. And u1 is this is u1 lah basically, yang keluar daripada bucket ni, equals to 50, this 50 minus 25. okay, untuk dapatkan this 25 meter per second. Ini sama juga macam yang saya inform awal-awal tadilah, adalah benda ni. okay, this one kan, nak dapat ni adalah V yang daripada water jet minus U U yang dekat sini this one kan, this V tolak U, kita akan dapat relative velocity. okay, so kita akan dapat this 25 meter per second. And then from this information and this information, kita boleh dapatkan the value of volume flow rate. okay, this volume flow rate is important sebab kita akan guna pakai dalam rumus ini yang tadi tu, resultant force tadi tu. okay, so kalau kita tengok dekat sini kan, condition dia a bit different sebab bucket dia bukan macam bucket biasa, dia ada sebelah je. Kalau ikut usual, dia ada dua belah kan, dia ada situ satu dan sini satu kan, yang mana water jet ni dia akan pecah sini satu dan pecah sini satu. okay, however this is a bit different, dia macam ada yang atas sahaja, yang mana water jet tu dia hanya tembak ke atas sahaja. So if let's say it is like this, tak ada masalah, sama je. Cumanya kita akan guna the same equations macam tadi. Cumanya kalau kita tengok dekat sini kan, kita pecah kepada dua komponen, ftx dengan fty, dan kita consider towards ke kanan adalah positif. So kalau kita tengok kat sini, u2 dia adalah this one okay, yang keluar ke atas tu u2 cos theta lah. Cos theta dia adalah apa? 20 degree bukan yang 160 tu 20. u2 cos theta minus u1 yang masuk ni lah kan. But however, since ke kanan adalah positif, that's why kita replace u2 ni sebagai negative 25 Tengok tanda tu sangat penting, dia negatif disebabkan direction dia ke kiri. Kita dah set direction ke kanan positif. So since dia ke kiri, so dia gerak ke sana, dia jadi minus. And then belah kanan ni adalah positif sebab u ni masuk ke kanan ke kanan 25. So yang ni kita maintain lah. In the end kita akan dapat ftx equals to, kita solve tu, tekan calculator, kita dapat this value. Okay, so kita dah selesai ftx, tapi fty dia tak simetri untuk this case. Dia bukannya macam yang ni. Kalau macam ni kita tahu the forces, total force in y direction is symmetry, so fty equals to 0. Okay, so for this time around fty dia ada value disebabkan dia punya condition sekarang hanya sebelah sahaja. So kita guna the same exact equations, however this time around kita guna y components kan. Kalau y components dekat bahagian sini tak ada lah. That's why u1 dia waktu dia start u1 ni, dia hanya bergerak horizontal, dia tak ada angle. So u1 dia kosong. Okay, ux dia since ke atas is positif, dia positif lah. Dia dapat 25 25 sin 20. Okay, and then kita dapat this value Okay. So since the question asks for force exerted on the vane, sama case macam tadi lah kan, the force exerted on the blade or on the vane is the same magnitude as the total forces but in the opposite direction. So dia hanya oppositekan value yang kita dapat ni untuk dapat force exerted on the vane. So kita dapat this value. Okay. So basically that is all for chapter 5. All the best. Apa-apa tak faham boleh tanya. Okay.